For section 1.4.5, we're going to pause and review some things that we've learned and recognize patterns in sine and cosine. To evaluate the 6 basic trigonometric functions or ratios, we have a few options so far. Number 1, we sketch the angle alpha in standard position and locate a point xy on the terminal side of the angle. This is very simple when evaluating the trigonometric functions at quadrantal angles. We can use points like 1, 0, 0, 1, -1, 0, and 0, -1 to evaluate the trig functions at the quadrantal angles. However, if the angle is a multiple of 45 degrees or pi over 4 radians, we can use a special 45, 45, 90 triangle to determine the trigonometric ratios. Similarly, if the angle is a multiple of 30 degrees or 60 degrees, or pi over 6 radians or pi over 3 radians, we can use a special 30, 60, 90 triangle to find a point on the terminal side and evaluate the trigonometric ratios. Another option is to begin observing and memorizing the patterns of values associated with sine and cosine of common angles. The special triangles are excellent and useful as we learn these values, but we're going to see the same common angles popping up in our trig functions consistently throughout the semester. So it's good to begin recognizing patterns in sine and cosine. Let's consider evaluating sine for the common angles in quadrant 1. That's 0 degrees through 90 degrees. First of all, notice that sine of 0 degrees is 0. Sine of 30 degrees is 1/2. Sine of 45 degrees is square root of 2 over 2. Sine of 60 degrees is square root of 3 over 2. And sine of 90 degrees is 1. Now, if I look at the patterns with the radicals in the column to the left, notice every single ratio has a denominator of 2. In addition, in the numerator, we have a value under the radical, and that value increases from 0 to 4. So we can think of this as square root of 0 over 2, square root of 1 over 2, square root of 2, 3, and 4 over 2, so on and so forth. Now, why would we want to do that? Well, you can use those patterns and your hand, either your left hand or your right hand, to quickly evaluate sine and cosine. Whether you're looking at your right hand or your left hand, consider 0 degrees to be represented by your thumb, 30 degrees by your pointer, 45 degrees by your middle finger, 60 degrees by your ring finger, and 90 degrees by your pinky. To evaluate sine of an angle, I'm going to count the number of fingers underneath that angle, and that's going to be the radicand in our pattern here. So, for example, if we want to evaluate sine of 60 degrees, notice there's 1, 2, 3 fingers below my ring finger. So I'm rotating from the ring finger to the thumb. So we have 3 fingers below, and notice for 60 degrees, sine of 60 degrees is square root of 3 over 2. Or let's suppose we want to evaluate sine of 30 degrees. So I'm going to count the number of fingers below 30 degrees. Notice there's 1 finger below 30 degrees. So for sine of 30 degrees, we're going to evaluate square root of 1 over 2, which of course reduces to 1/2. To consider one more angle, let's find sine of 90 degrees. So I'm going to count the number of fingers below 90 degrees. That's 1, 2, 3, 4. So that's the number we put underneath the radical. Square root of 4 is 2, and 2 over 2 is 1. So it's just a tool to help you begin recognizing patterns. Similar patterns emerge for cosine. Now, notice again, our angles are increasing from 0 degrees to 90 degrees. Again, we've got a 2 in the denominator for all of these ratios, but now we're going to start with a radicand of 4 and decrease down to a radicand of 1. To evaluate cosine of an angle, I'm going to count the fingers above the one that represents the angle. So, for example, let's suppose we want to calculate cosine of 60 degrees. I'm going to count the number of fingers above that angle. Notice I have 1, and that's the value that goes under the radical. So, cosine of 60 degrees, when we simplify, would be 1/2. Let's calculate cosine of 0 degrees. Notice there's 1, 2, 3, 4 fingers above 0 degrees, so we'll evaluate square root of 4 over 2. Square root of 4 is 2. 2 over 2 is 1. So cosine is going to yield similar values for the ratio. They're just in a little bit different order. The hand trick is a useful tool to quickly get to know these patterns. So remember, for sine of an angle, we're going to count the fingers below or toward the thumb. So find the finger represented by the angle and count fingers below for sine. To evaluate cosine, you're going to count fingers above. And we're talking about fingers above the finger represented by that angle. So I'm counting the number of fingers towards the pinky. So kind of a neat tool to use to help you begin recognizing patterns. Ultimately, you want to be able to quickly evaluate sine and cosine for all of the common angles, either in degrees or radians, on our unit circle. We'll get there. We're going to learn a lot of tools to help us do that. So I suppose we could come back up here and add option number 4, the hand trick. Ultimately, we need a point on the terminal side of the angle to evaluate the 6 trigonometric ratios, or we can use the special 45-45-90 and 30-60-90 triangles to evaluate the trigonometric ratios, or we can use the hand trick. Hope that helps.